Hello, class. Hope you're doing well. I wanted to introduce to you material from Chapter 5, which is on measurement concepts. So we'll be talking over a few things today, and then after that, if you have any questions or you need any further clarification, please, as always, feel free to schedule some office hours with me. I'm happy to answer any of those questions. In Chapter 5, the entire chapter really deals with these measurement concepts. So last chapter, we talked about experimental versus non-experimental designs. And now we're going to kind of get into a little bit more of the nitty-gritty associated with how we are conducting research. So some of, again, more of the nuances of the research process. So we talked about variables in Chapter 4, but variables are going to be a general class or category of objects, events, or situations. So variables themselves have to be defined. And we talked about this defining of variables. We do this with an operational definition, right? And we have to define a variable because we really need to study it. So we might make a statement, or you might hear a statement, I work better under pressure. That very well may be true. In fact, I hear a lot of students talking about this. If that's the case, we have to find some way to be able to empirically study if a person really works better under pressure, right? What does that mean? And so here again, kind of getting into that operational definition. What is pressure? What is work? How do we define that work? How do we define that pressure, right? So we also have different classifications of variables as well. We have situational variables. These are going to describe characteristics of a situation, of an environment. Some of the examples that you might find in your book are related to word length or spatial density, credibility, etc. We have response variables, and these are the ways in which we are responding or maybe more simply behaviors of an individual. And this can be related to things like reaction time, the proportion of correct responses, aggression scores, for example. And then we also have subject or individual difference variables. These are characteristics that are going to be different based on each individual person. So this could be gender or intelligence or personality traits. So kind of getting back to that variable we talked about, getting back to that classification. How do we empirically study something? So we've talked about this in our last chapter with our operational definition. Okay, and now we're going to get into this just in a little bit greater detail. So we have to be able to define a variable in terms of the operations or techniques the researcher is going to use to measure or manipulate that variable. We need an operational definition because as scientists, we might have very abstract concepts, but we are trying to study it in concrete terms. So we really need to ask ourselves a couple of questions, right? When we're trying to make a research study. Is the concept too vague? Maybe it is, right? And sometimes we have really great intentions and want to study a concept, but we simply cannot because we don't really have those concrete terms to be able to study it. We might also need to think about if we need a little bit more reflective thought or background research in order to be able to come up with that good operational definition. So for example, we might have a hypothesis that frustration is a precursor to aggression. This very well could be true, but what does past literature say about this? How is frustration and aggression operationally defined in previous research. And then we, have to come up with a measurement that we're going to use to operationally define these variables. Will it be for aggression? Is it the number of times somebody is hitting somebody else? Is it the number of times a person is making rude comments to somebody else, right? So we also need to have that measurement that we'll then be using. In some cases, we could have already existing surveys. When we get to our survey chapter, we'll kind of get into a little bit greater detail about what surveys are and maybe how we could use them. But this kind of gives you the beginning stages of your research study. I had this professor in graduate school, and she always used to say, garbage in is garbage out. So if you come up with a research study, you do not spend ample time doing the study. If you're not creating this really good operational definition, it's basically garbage, it's noise. And so whatever results you find out based on that definition you've used or the study parameters you've used will be equally garbage, right? Because it doesn't really mean anything. And a lot of times we fail to understand, or I guess people, when they aren't really aware of the research process, really fail to understand how much effort and time it takes on the front end to be able to produce a really good quality research study on the back end. And so we really need to be, really provide a lot of detail when we are conducting these research studies. We have to spend a lot of time when we're creating those methods for a research project. Your book then goes on to talk about reliability. Now, reliability is a reliable measure is both stable and precise. It's free from random error. And we really want this measurement to be free from that error, right? Or random error. A reliable measure is consistent and it's stable as well. So every measure has two components. You can kind of think about it like this. If we get a measure on a test, if I look at a score on a test, so if I give you, say, an IQ test, it's going to spit back out a score on that test. But that score is a combination of your true score and then any error that's associated with the test that we're using, if that makes sense. So our measure is actually a combination of what you scored on the test plus any error that exists. So reliability in general is most likely to be achieved when researchers use careful measurement procedures. So you are training your observers, you are using appropriate phrasing, the instruments that you're using are sound. Every step in the process of you conducting your research study can introduce error. And we want to eliminate the amount of error that exists so that way our measurement is much more accurately represented of a person's score. So thinking about this reliability, we really need to have consistency and stability of a measure. Okay, so we kind of talked about these two components. We have our true score and our measurement error. And as I mentioned on our previous page, our true score is going to be the real score that we've gotten. So on an IQ test, the actual score that we earned. But our measurement error is this unreliable measure of intelligence. Unreliable measure of intelligence contains considerable measurement error, and so that's not really providing an accurate indication of that person's true intelligence. This could be, so what does that mean, right? So this could be, I'll give you an example. We've kind of talked about this, and we'll get to this a little bit more when we get to kind of survey designs or survey questions. There was a multiple choice question. And I think it was on the SAT, and it was talking about how Johnny got on his yacht and then sailed 15 nautical miles and landed on a small island. And from that small island, he traveled north and traveled an additional 20 nautical miles. How many nautical miles did he travel? Now, if you don't know what a yacht is, you may actually get this question incorrect, right? Not because you can't do math, but you don't understand certain parts of that question. So this would be part of that error that we're sort of talking about here. It doesn't accurately provide an indication of your true intelligence, because the question might be confusing for you because you have no idea what a yacht is, right? So our error actually includes both systematic error and random error. So this is, if we kind of take it one step further, our measure is actually our true score plus our systematic error plus our random error. Okay, so our true score is the true score, right, that we got. Our systematic error is other factors. And then we've got our random error. So this could be coding error or something like that. When we get into the survey section, I'm actually going to show you a program that you can use instead to collect data. When I was in undergrad, actually even into grad school, at least for the first couple of years in grad school, we actually used to use paper and pencil surveys. That's what people used. In undergrad, I was actually a research assistant in a professor's lab. And literally my job, right, what I did was I entered in data. So they would hand me this stack of papers of surveys that other people had done and finished. And then I literally would go through and type the data into an Excel spreadsheet. Now, anytime we do this, we're introducing error. I mean, I'm sitting here, just think about how monotonous the task is, right? So I'm sitting here, I'm writing, I'm doing this, I'm typing it in. And people are bound to make mistakes. And so how they would deal with that is, for every stack of surveys, they would have 2 undergraduates enter in data. So I would enter in data, and then there was another undergrad research assistant who used to enter in data, and then they would run a statistical program to compare our answers with each other. And then any discrepancies between what I entered and the other person entered could be verified. And this sort of allowed for that reduction in this random error that could potentially affect the results. So kind of comparing the data of a reliable and unreliable measure. A reliable measure, if you kind of look at this, has, a lot less variation, right? I mean, the variation between this person and this person is a lot less than this unreliable measure. Look how much difference we can kind of get here. So again, we really want that reliability in our measure. Okay, so the problem here, and as you've probably been reading about, we can't actually directly observe a true score and error components. So what do we do? What can we do here? In this case, we can use something called correlation coefficients. I hope your next question is, well, what the heck is that, Dr. E? Well, correlation coefficients show us how strongly 2 variables are related to each other. So remember whenever I talked to you about correlations in one of our earlier chapters, and you saw kind of these lines going up or down, when we've got data points, we can actually look at the strength of how much each of these variables relate to each other, right? So with the kind of more money is related to more problems, there's a relationship there. And we can actually look at the correlation coefficient. The strongest correlation is something that's either +1 or -1. That means it's perfect correlation. So as one item increases, the other also equally increases, or vice versa. As one item decreases, the other item also equally decreases. It's important to note that finding a perfect correlation in research is pretty much near impossible. You won't see that. Instead, we would consider, and there are kind of different benchmarks for this. You'll probably talk about this a lot more in statistics. If you see something in the 0.7 to 0.8 range, we would consider this to be a pretty decent correlation. And so, you probably aren't going to see something that's +1 or -1. Now, the other point to remember here is that this positive and negative sign, what this tells us is not necessarily the strength of the relationship. It tells us the directionality of the relationship. So whether that line is going up, being positive, or going down, being negative. So a +1 and a -1 correlation are actually the exact same in strength. You can actually consider these to be an absolute value if that helps you kind of going back to your earlier math days. What else can we do? Well, we can do something called retest reliability, which is giving the exact same survey or giving the exact same test to a person. If our way of measuring something is accurate, how I respond to your survey now and how I respond to your survey 4 months from now or a year from now should actually be very similar. I should score pretty similarly in scores. And so we would treat this as a repeated measures design whenever you get into statistics. So this is one way kind of for us to take a look at that. Okay, so with that, I'm going to go ahead and end us here. There's still some other material left in this chapter related to validity as well. And of course, if you have any questions, you kind of want to touch back on any of these items, by any means, please reach out to me. I hope that this chapter now makes just a little bit more sense, maybe, and kind of makes that reading a little bit easier. I hope you have a wonderful rest of your day, and I look forward to seeing you in class or office hours soon. Have a good one.